Hello everyone, we will talk about implemented classes in C, C++. This is part 3, the last part of a 3-part discussion about classes. And in this part we'll discuss about classes in context of dynamic memory, more about constructor and local classes. If a dynamic variable is an object of a class, then the default constructor will be called to initialize a new class instance. For example, let's say we have pptr, a pointer to an object of type write, and we declare pptr equal new of write. In this case, the default constructor is called because there are no arguments. But if you place arguments right after the type name, a different constructor will be called. For example, if you declare tptr, which is a pointer to an object of type write, and then you have tptr equal new write, and then 4 arguments, then the constructor with 4 parameters is called. Dynamic memory is allocated from so-called heap for dynamic variables and dynamic arrays. Even though the heap is very large, when it runs out of space, the operator new used for allocating dynamic memory fails, and it causes a bad alloc exception. An exception usually prints an error message and terminates the program. One can catch the exception and try to fix the problem without having the program to terminate. Older version of C++ indicates the failure of the operator new by returning a special pointer called null pointer. An error message will be printed and the program will stop. This older behavior can be obtained if, instead of calling the operator new, the programmer call operator new of no-throw. To use the word no-throw, which is a constant, one needs to use the include directory with new. A default argument for a function is a value used for an argument of a function when no actual argument is provided in the calling. A default argument may be listed in the prototype of any function, whether it's a function member or it's a simple function. A function with several arguments doesn't need to have a default value for all the arguments. The one with default values must be the rightmost in the parameter list. In a function call, arguments with default value may be omitted from the right end of the actual argument list. The syntax in a prototype's parameter list for a function is as follows. We have the type name and then the name of the variable equal and the default value. For example, for an object of type write, if we declare string ini n equal it, int ini d equal 5, int ini w equal 120, int ini l equal l, that's l not 1. That means so that the constructor for the class write will have 4 parameters. All 4 parameters have default values, and these default values will be used in case when we call the object, we do not include some of them. The default values are specified only once, in the prototype, and not in the function implementation. For example, if we have the object write7 of type write, and the object has been declared with 4 arguments, then we have the constructor with 4 arguments being called. If we have another object, write8, which is of type write, and we call only with 3 arguments, then we will specify the first argument will be meet, the second argument which is specified it's 10, the third argument which is specified it's 0, and then for the fourth argument we'll get the default value which is 1. If you have the object write9 and has no arguments, then we will use each of the default values for the argument. So the first argument will have the value string it, the second argument will have the value 5, which is default, the third argument will have the value 120, which is default, and the last argument, the fourth argument, will have the value 1, which is by default. For object of write9, the default constructor is called. To simplify, one can provide a single constructor with a complete set of default arguments instead of having multiple constructors with various number of arguments. you need to use const at the end of the function if the function does not change the value of the calling object. For example, the write time can be declared as const because inside the definition of class write, because it does not change any of the data members. It just computes based on the data members the total write time. You can also use const for a formal parameter if the function does not alter the parameter. For example, for total time, and total time will be the total time of the write 1 and the total time of write 2. We have two arguments, write 1 and write 2. These are objects of class write, and these are const objects. Therefore, the function total time can have const object because these objects will not be changed inside the function total time. What happens if the type of a function returned is a class? If a function returns an object of a certain class, the return statement will use a copy constructor to copy the function return value, which is the object, to a temporary location before returning the value to the callee program. Let's assume that the class write has an additional public member function called increaseWait, which has a single argument of type integer, and that will increase the value of the private member write delay by the argument provided. The ordinary function writeAgain returns an object of class write. So the function writeAgain is an ordinary function which returns an object of type write. It has two arguments. Neither of the arguments gets changed, therefore they can be passed by const reference. And the function return, it's a duplicate of the current write, but with an extra delay. So we declare an object new write, which uses a copy constructor to copy all the data members from the object R, which is a formal parameter, and we increase the wait time by the delay for the new object, which is new write, and then we return the object which is new write. The member initialization list appears in the implementation of a constructor after the closing parenthesis of the parameter list, but before the open bracket of the constructor body. It is optional if you want to use a member initialization list. The list begins with a colon, followed by a list of items separated by commas. If you have a single item, no need to use a comma. The list can also contain any member variable followed by its initial value in parentheses. If you have a derived class, the list can contain the name of the base class followed by an argument list in parentheses for the base class constructor. When the derived class constructor is called, the member variables are initialized with the specified values, and the constructor for the base class will be activated before anything else is done. Class declaration can also include static and non-static data members and function members, member type definitions, member enumerations, nested classes, and friend declaration. For example, class S has an integer data member, D1, and this is a non-static data member. It has an array A of 10 integers, and we initialize the data member with two values, 1 and 2. This will work for C++ 11 and newer versions. And we initialize a third data member, D2, which is a const integer, but it's static. So this static data member, which is initialized, will be shared and will have the same value for all the objects which are instances of class S. And because it's a const int, this data member cannot be changed. And then we can have a virtual function, f1, which has a single argument, and we declare this function to return void, because pure virtual member function typically return void. And then we have more data members, which are non-static. So we have D3, which is of type string, D4, which is a pointer to a string, and we have the function f2, which returns returns a string and has a single argument of type integers. Because we use the keyword class all these data members are private. A non-static data member cannot have the same name as the name of the class if at least one user-defined constructor is present. The auto specifier cannot be used in a non-static data member declaration. Although it is allowed for static data members, they are initialized in the class definition. You can read more at cppreference.com, and the link is provided. A default member initializer is a brace or equals initializer included in the member declaration and is used if the member is omitted from the member initialization list of a constructor. For example, for the class write, we have a data member write name, and it's initialized with 3 characters, E, A, and T. We have duration equal 5, location equal 1, write weight equal 45. And then we have function member, which are of type public. A default member initializer is a brace or equals initializer included in the member declaration, and it's used if the member is omitted from the member initialization list of a constructor. For example, we have the class write, which has the first data member write name, which is initialized with 3 characters, E, A, and T, the write duration, which is initialized to 5, the write location initialized to 1, write weight initialized with 45, and then we have a function member set values, which set values for all the 4 data members, and then we have the function write time, which returns the total write time and has a single integer argument. If a member has a default member initializer and also appear in the member initialization list in constructor, the default member initializer is ignored for that constructor. For example, let's say that we have the class T, which has one data member year equal 2020. So this is what is default member initializer. And then it has a default constructor, which does nothing. And then we have a second constructor, which has a single argument, and that argument will be set for the data member year. In the second case, in the second constructor, the member initialization, the default member initializer of 2020 is ignored, and we use instead the member initialization. If we declare an object C1 of type T, C1.year will be 2020. If we declare a second object C2, which has the argument 2001, C2.year will be 2001, and the default value 2020, which was part of the default member initializer, will be ignored. Default member initializers are not allowed for built-in members until C++20. The default member initializers are not allowed to cause the implicit definition of a default constructor for the enclosing class or the exception specification of that constructor. So let's say that we have a struct node and we have a data member which is a pointer to a node, and we set it equal new node. This will create an error and due to implicit or defaulted node of node. Members of type array cannot deduce their size from member initializer. Let's say that we have another struct X, and it has 2 data members, array A, which has 3 values 1 to 3, and array B, which has 3 values 1 to 3. Int A and no size, it will be given an error because it cannot deduce the size from the initializer. But the second data member B, it's okay because we declare the size to be 3. You can find more example at cppreference.com, and the link is provided. The order of member initializer in the list is irrelevant. The actual order of initialization is as follows. If the constructor is for the most derived class, the virtual bases are initialized in the order in which they appear in the depth first, left to right traversal of the base class declaration. Left to right refers to the appearance in the base specifier list. Then direct bases are initialized in left to right order as they appear in the class base specifier list. The non-static data member are initialized in order of declaration in the class definition. And finally, the body of the constructor is executed. Note: if initialization order was controlled by the appearances in the member initializer list of different constructors, then the destructor won't be able to ensure that the order of destruction is the reverse order of the construction. Local classes are classes in which the class declaration appears inside of another function or another class. The name of such a class only exists within the class or the function scope, and is not accessible outside the function or outside the class. A local class inside a function, including member function, can access the same names that the enclosing function can access. There are some restrictions for local classes. A local class cannot have static data members, friend templates, or friend functions. The member functions of a local class have no linkage. The member functions of a local class must be defined entirely inside the class body. The local classes other than the closure types, which are seen in C++14, cannot have member templates. The local classes cannot be used as template arguments until C++11. This concludes part 3 of classes, and this concludes the presentation of classes. Thank you for listening.